Okay, what is the slope of the linear function shown in the graph? Remember, slope is, we represent it by m. M equals rise over run. Just get in the habit of saying slope is rise over run. So anytime you see slope in a problem, just replace it with rise over run, and that will help you to remember what slope means and how to find it. Okay, so you look at the line, and I'm going to pick 2 points on the line. Really, you could pick any 2 points. I like to pick points that are easy to see, like maybe these two. Those 2 points look like they go through right through the intersections there. Okay. And you want to measure the rise and the run. So always read from left to right, just like you read a book. You go from this point on the left to this point on the right. The rise from here to here is, it's going down, it goes down 1, 2. So the rise is 2, but since it's going down, it's -2. Okay? And then from here to here, the run is 1, 2, 3, 4. And the run will always be positive. If you're going left to right, that's a positive run. Okay? As a rule, we're always going to be going left to right. So the run is always going to be positive. The rise will be either positive or negative, depending on whether it's going up or down. Up is positive, down is negative. Okay? This one was going down, so it's negative. And then you reduce that fraction to -1/2. If you don't know how to reduce a fraction, there's an easy way to do it on your calculator. If you punch in -2 divided by 4 on your calculator and hit enter, you're going to get -0.5. Okay, so that's the decimal equivalent. And if you want to convert that back to a fraction in simplest form, what it will effectively do is reduce this fraction down to its reduced form. So once you get this answer, then you hit the math key on the calculator right here. You punch the math key, and let's see what we've got here. When you hit the math key, you're going to have a list of functions there. The first function says FRAC, and it's already highlighted, so all you have to do is hit enter, and hit enter one more time, and it will give you the reduced fraction, -1/2. So that's a nice little skill to learn, which you'll use quite a bit. If you know how to do that, you'll never have to reduce a fraction by hand. You can let your calculator do it. Okay, so -1/2 is the slope, which means this line is going down 1 over 2. And it's always doing that. It's going down 1 over 2. See that? Down 1 over 2. Down 1 over 2. Okay, number 2, what's the slope? Okay, same thing. I'm going to pick a couple of points here. Okay, from here to here, we're going down 1, 2, 3, 4, 5, and over 2. So the slope is -5 over 2. Answer A. in the distance formula, D equals RT. R represents the rate of change or slope. Okay, so there's that word again, slope. Okay, which ray on the graph best represents a slope of 20 meters per second? Okay, so really, a lot of this is unnecessary information. You mainly just need to find the slope here, 20 meters per second. So if you look at this ray right here, and you calculate the slope, pick a couple of points on it, look at the rise, it rises 20 and it runs 1. So slope is 20 over 1, which is 20. And that is ray O. So answer C.
10 minutes?
Yeah.
This is Friday.
Because I'll put it away if you don't want.
No,
Okay.
I'll be back. About 15, 20 minutes.
Okay. Same thing on number 2. Slope. Now we're looking for a slope of 200. So you look at the different rays and you find one that has a slope of 200. In other words, it rises 200 as it runs 1. I can tell these two are not nearly steep enough. So let's look at these. If you look at this one that's the steepest, look how it goes up. It goes up from 200 up to 400, and as it does that, it runs from 0 to 1. So that rise is from 200 to 400 is 200, and the run is 1. So 200 over 1 equals a slope of 200. That is ray J. Okay. So the answer on number 1 was C. The answer on number 2 was A. Okay. On number 1, it says the line segment shows the depth of a submarine from the time it submerges to the time it reaches cruising depth. Which of the following best describes the slope of the line? So you want to look at your slope here, and you want to pick a point. I'm just going to pick this first point right here. If you'll notice, it's moving 50 feet down, or submerging. We'll say submerges 50 feet every, what is this? 10 minutes. From 0 to 10 minutes. So every 10 minutes. If you reduce that fraction, you get 5 feet per minute. So answer A. That's how you do those. Number 2. Well, it looks like it's going, we'll pick that point right there. You always want to try to find the points that meet right at the intersections of these horizontal and vertical lines. And it looks like this is one, and the next one is right here. Okay, what is the rise? Well, it's going down from 200 to 120. That's a drop of 80 miles. And the time from there to there is 0 to 100, so 100 minutes. Okay? Reduce that fraction. Now this is one that's not going to come out exact. This one's going to come out to 4 miles every 5 minutes once you reduce it. That's real close to this one. These other answers, especially answers B and C, those don't make sense. 60 miles every 5 minutes, because that would mean you're going 60 miles in 5 minutes. From 200 down to 140 in 5 minutes. Remember, 5 minutes is a tiny little piece right here. Okay, so it's definitely not B. 20 miles every minute, same thing. Okay, I mean, they're taking 20 minutes to go, just to go 20 miles here. So B and C definitely can't be right. 5 miles every 8 minutes, that's a little closer. If you're not sure, go ahead and go all the way down like that and look at the slope. From there to there, your rise is from 200 down to 0, which is negative 200. And we'll just call it positive 200. Really, the sign here doesn't matter, because we're not talking about a drop or a decrease. It's just how many miles did they drive in this many minutes. So we went 200 miles in how many minutes? There's 220, so the next vertical line would be 240. 240. Reduce that. Use your calculator to reduce, like I just showed you, and you will get 5/6. So if you use these 2 points, you're going to get the exact answer. Answer A. 5 miles every 6 minutes. But at the very least, you should have been able to rule out B and C. Okay? From this question. Okay. The graph of a line contains these points as shown below. 6, 2, 1, 2, 3, 4, 5, 6, 1, 2. There's 6, 2, and 3, negative 1. So there's those 2 points. Now down here they want to know if this slope of this line is halved and the y-intercept is increased by 2. Okay? So we're taking this line, we're going to cut the slope in half, and we're going to increase the y-intercept by 2. Okay? Well, look, here's the y-intercept right here at negative 4. If we increase that by 2, we should go up to our y-intercept is going to be right there at negative 2. So find a line that has a y-intercept of negative 2. Well, here it is. That's the only one, because this y-intercept is down here, this y-intercept is down here, this y-intercept is at negative 1. Okay, this is the only one that it can be. The slope is halved. Look at the slope of these lines. We go up 4 over 4 for a slope of 1. Well, what's half of 1? We want to half the slope. So what's half of 1? 1/2. Just 1/2 of 1, or 1/2 times 1. And I can write 1 like that. When I multiply those, I just get 1/2. So the slope is 1/2. Well, look at this slope. Up 2 over 4. That reduces to 1/2. Okay, but you didn't even need to do that to get this answer. Just by looking at the y-intercepts, you should have been able to tell this was the only one that will work. Okay, so answer A. Okay, here we've got a line, and we want to keep the slope the same and increase the y-intercept by 3. Okay, look at your y-intercept. For this one, the y-intercept is at positive 4. If you increase that by 3, you're going to increase it up to here where y is 7. And look at your lines down here. Which one has a y-intercept of 7? Right there. Answer D. Slope is the same. They both have a slope of 1/2. Okay. If you want to count that out, go ahead and do that. But this has a slope of 1/2. This has a slope of 1/2. But you really don't even need to know that to get this question right. All you have to do is look at the y-intercepts. Okay, here we go. Okay. This graph shows number of words typed by a student typing at a rate of 40 words per minute. 40 words per minute is a rate, but it's also the slope of this line. Okay? Look at this. The rise from here to here is 40, and the run is from here to here, from 0 to 1 is 1. Okay? So the slope is 40. Okay, now down here, W is the number of words typed and M is the number of minutes. Which graph represents the number of words typed by a student who types at the rate of 10 words per minute? So now the slope is 10. It's 10 words per 1 minute. That's where we're getting this rate or slope. Okay? It's 10 over 1. If you look at your graphs, D goes up 20. Between these 2 points, it goes up 20 and over 2. Up 20 over 2. And that reduces to 10. 10 over 1, or just 10. Okay, so the answer is D. Same thing here. This is the distance traveled by a bicyclist pedaling at a rate of 6 miles per hour. So they're going 6 miles in 1 hour. Okay. 6 miles in 1 hour. 1 is right here, so 6 miles in 1 hour. Okay. Now down here, we want to find one that represents 12 miles per hour. A rate of 12 miles per hour. So instead of 6, it's going to be 12. This one, they go 6 miles in 2 hours, which would reduce to 3 miles per hour, so that's wrong. This one, 12 miles in 2 hours. Okay, look at your graph. Goes up to 12 in 2 hours. That reduces to 6/1, so that's wrong. Remember, we want 12 miles per hour. Answer C, look at that one. It goes up to 24 in 2 hours. That reduces to 12 miles per 1 hour. So that is the answer.
In their life, good and bad, to make them stronger, which allows for change to take place. One such example of making positive choices and not letting the choices and actions of others keeping them from excelling is Denise Perez. This young lady has proven that a